So I will start by maybe explaining what an EPD is. And in a nutshell, an EPD documents the environmental footprint of a product. But before we go in details of what an EPD actually documents and also how does it document it, let's first ask a first simple question. So why do we need EPDs? So here we will start with a very quick summary of what are CO2 equivalent or CO2e scopes, as this will come later into play when explaining where the EPD emissions are accounted. The definition of scopes has been done by the Greenhouse Gas Protocol, an NGO business partnership, and it is today used by almost all large corporations in the world, including Siemens. So the greenhouse gases not only include CO2, but also other gases, as you see on top of the graph here, such as methane and SF6. So as per this definition, the scope 1 of a company will be for all its direct emissions, for instance, its emissions coming from its own energy supply, its gas heating, its SF6 losses, etc. The scope 2 will account for all CO2e emissions linked to the purchase of energy. And the scope 3 will be split into one part upstream, notably including the supply chain emissions, so the emissions of all your suppliers, and one part downstream, which will notably account for all emissions of the products of the company when used by its customers. Now, let's see an important aspect of why EPDs become more and more important. So here, as you can see, we have draft climate disclosures guidelines from the EU Commission, the SEC in the US, so Securities Exchange Commission, and the accounting system IFRS, which will all make mandatory for corporations the reporting of CO2e emissions for scopes 1 and 2, and in many cases for scope 3 as well. So many companies already report the scope, you can see that on the bottom here, but this will become a general requirement in the future. So we will come to the utility of EPDs for the reporting of scopes a bit later in the webinar. And finally, manufacturers and customers may also benefit from EPDs. Manufacturers, in order to issue an EPD, very often will need to have an internal quantitative assessment of the environmental impact of their product, called a life cycle assessment. And this assessment will bring quite a lot of learnings from where the CO2e emissions of the product come from. And therefore will give opportunities, for instance to Siemens, to consider them in the next redesign of the product. And we believe also that as sustainability becomes more and more a topic for corporations, we need, as Siemens, to provide our customers with the information they will need. So for customers, the use of an EPD will be discussed during the webinar. But we can see here a statement that we have taken from a third-party certification agency website. So this statement is that EPDs provide a basis for comparison of products. And we will explain our view on this statement a bit later. Now, to start the understanding of what an EPD is, we will show first the 3 different types of EPDs. So here, this is the EPD type 1, which will not be a focus of this webinar. And this is basically a third-party certification that your product can use an environmental label for marketing purposes. So this is mostly for B2C business and household products. So again, not a focus of the webinar today. Now, the type 2 EPD is a self-declaration from the manufacturer. So this kind of EPD must follow the ISO 14021, but does not mandatorily require having an LCA. So the ISO 14021 mandates that the claim must be careful, not misleading, clear, and specific. So Siemens uses extensively type 2 EPDs for its products. But in addition of following the ISO standard, we also decided to do an LCA for each EPD we create, following the required ISO 14040 and 14044 standards for the LCA. So this is the same requirement to be followed to publish a Type 3 EPD. therefore offering the same transparency in our type 2 APDs that what you would get from a type 3 APD. One of the first things to realize when reading an EPD is that the product that the EPD documents will almost always not be the exact version of the product you are buying, but will be a member of a family of products called an HPF. We will explain what an HPF is a bit later in the webinar. But it is important to note that because the product is not the same, the emissions also won't be exactly the same as the product you will purchase. And this is true not only for EPD type 2, but also for our last type of EPD on the list, type 3 EPDs. So I mentioned type 3 EPDs already a few times here, and type 3 EPDs are third-party certified. So you need to follow the ISO 14025 standard, and your LCA needs to follow the ISO 14040 and 14044 standards that I mentioned previously. So the process is that you will need to do your LCA according to a set of rules defined by the EPD system or the EPD certification agency, and the verification agency will verify that your LCA has followed these rules and that you cover in your calculation all the necessary input, and that the data sources of your input into the calculation are also documented. Now, there are a few things that I would like to highlight about EPD certification. The first thing is that there are many EPD systems around the world. Unfortunately, not all systems recognize each other, meaning that an EPD done in one system may not be accepted by another system. So obviously this puts a burden on manufacturers, as LCAs and EPDs are time-consuming exercise. The second topic I'd like to highlight is that EPD systems may use also different set of rules for conducting an LCA, meaning that the EPD results of the same product may differ from one system to another, which obviously is not ideal. And finally, the verification of your LCA doesn't mean that your final emissions figure is correct, but it means that you have followed the proper process and that you have also documented your input and documented your calculation. So not every single data input is verified by the verification agency, which is absolutely normal, as the certification only refers to the process that has been followed to do the assessment and calculate the impact. So I realize I may sound a bit negative here about EPDs and their usage, but I would like to leave this slide with a note that the EPDs are the only documentation available today for a product's environmental footprint. And that I believe that we are still at the beginning of the journey when talking about EPDs. So there are initiatives such as the Product Eco-Footprint, or PEF, from the EU Commission or from the International Electrotechnical Commission, or IEC, to improve the standardization of the assumptions made inside LCAs and EPDs. So as I mentioned before, currently in Siemens, the preferred type of communication to consumers, any kind of other parties about our products regarding their environmental performance is an EPD type 2, but always including a life cycle assessment according to the ISO standards. So we have chosen this approach because it guarantees a high degree of flexibility, but also ensuring compliance with applicable international rules, regulation, and also allows us to incorporate the latest knowledge and technologies. Now, let's move to the topic of life cycle assessments, or LCAs. So an LCA is an internal and confidential document from the manufacturer, and the LCA results will be then summarized in the EPD. So you can see here the 5 phases of an LCA according to the ISO norm. And we as Siemens follow this process. So you need to start by setting the goal and scope of the assessment study. So in short, first you need to select the product that you will assess. But as I've mentioned before, this decision already will have some impact on the final results of the EPD, as the emissions will depend on the product configuration you choose for the evaluation. This scope here the scope, will indicate which part of the life cycle you decide to document. So you have LCAs, for instance, for cradle to gate, which stops the documentation at the gate of the factory, or for cradle to grave, which will also include the operation and end-of-life impacts, or for cradle to cradle, which will at the end include the recycling portion of the product. Now, what do we do after we have defined scope and products? Then we do a life cycle inventory, where we will document every environmental impact throughout the life cycle scope of the product. So here we are really facing a difficult task. So we may have a very large number of suppliers for one product, and we need to account for the CO2e emission of every single component of the bill of materials, down to every single screw and nuts. So additionally, we need also to account for the manufacturing process, including, for instance, every minute that we spend on the assembly line. So as you can imagine, this is not an easy task. So we also make assumptions on several criteria here. And as these assumptions are not standardized across manufacturers and certification agencies, you may obtain different results depending on the assumption you make. And finally, for the LCA topic, I would like to explain more in details two concepts that I mentioned before. The first is the Product Category Rules, or PCR. So this document lists down the rules under which the LCA should be done. One example of non-standardization having an impact on the results is the lifetime of the equipment. So our products will have, for instance, resistive losses, joule losses, during the lifetime of the equipment. So we are making assumptions on the load under which the equipment operates, on the source of energy, and on the number of years the equipment will operate to calculate the emissions. Some PCRs will fix a lifetime of 20 years, while others, for instance the ones that we use in Siemens, will use 40 years, doubling the emissions in the second case. So PCRs have really a strong impact on the final emissions documented for the product. The next concept that I would like to talk about is the one of homogeneous product families, or HPF. So what it means is that when we do an EPD, we will use a certain configuration of a product or a certain product. For instance, maybe we'll use a circuit breaker configuration rather than a switch. And that these results of this EPD can then be extrapolated to other members of the family. Again, with this example of circuit breaker and switch. So there are certain rules to be applied when creating an HPF, such as making sure that all the members of the family have a similar functionality. So for instance, you will not put a bus bar inside a low voltage switchgear HPF. The HPF, the different members of the family of the HPF should also use similar materials, but this is still allowing manufacturers to limit the number of EPDs they do. So for instance, our electrical products business has tens of thousands of different final products, and it would be impossible to have an EPD for each one of them. So this is completely logical that we are allowed to do this. But as extrapolation rules are not well defined, it also means that the emissions of the product you'll buy can only be approximated from the emissions of the representative product of the same HPF for which we would have developed an EPD.